Hello, everyone. Yeah, thanks so much for joining us. As well as that, if you can put in the chat where everyone's hailing from, that would be really awesome to see where folks are joining in from, because of course, space is for everybody and space is universal. There's an awful lot of it. So yeah, I'm really excited about this course. I'm just going to share my screen and then Elise can tell me if everyone can see this. Does that
Looking
look
good.
Looking good, brilliant. So yeah, this has been a long time coming and a long time in the making, and we're really excited to be able to launch this postgraduate taught master's course in space science this upcoming year. Um, the reason we wanted to do this is basically like we've got all the skills at the University of Glasgow to be able to deliver a bespoke course that basically plugs straight into the UK and international space sector. So this combines three of our kind of big schools in the School of Geographical and in the College of Science and Engineering, which is the School of Geographical and Earth Sciences, the School of Physics and Astronomy, um, and the James Watt School of Engineering. To basically give you a kind of complete overview of the discipline of space science and give you the skills humanity is going to require to literally reach for the stars. So, a little bit about the team. Um, the kind of two principal people who will be like looking after you during this course is myself and Dr. Lydia Hallis, pictured here. So our research is in kind of planetary science, which is the kind of terrestrial body arm of space science, and we specifically study the very, very small in order to understand the very, very big, to essentially try and understand some of these really big esoteric questions, like how do you build a planet in the first place, and how does a planet like our Earth become a habitable world where life is able to emerge on it, and we can have these wonderful conversations like we're having today. Um, Lydia herself is doing some amazing work with the Mars Sample Return Mission campaign, which is a kind of combined effort between the European Space Agency and NASA to bring back rocks from the Red Planet. And I used to be part of the Japanese Space Agency's Hayabusa and Hayabusa 2 asteroid sample return missions. So and we have both have a deep-seated kind of expertise in planetary geology and also understanding about how space missions work and operate. So we'll be kind of doing the lion's share of the teaching on this course alongside our colleagues in physics and engineering, and I'm really looking forward to kind of welcoming you to this course and looking after you with your time here during your time here. Now, the main motivation for wanting to build this course Space Agency and in line with the UK government, published a report a few years ago describing a skills gap between graduate skills and the needs of the UK space sector and wider international space sector. And it's massive. So there's a huge demand from industry, from the space sector, for skilled graduates in a variety of disciplines. And while I'm not going to say that this course is going to be a one-stop shop that solves all the UK's space needs, we are going to target some of the big gaps with this course, specifically looking at software and data, processing that data in a downstream way, so interrogating data being beamed back from satellites, both observation of the Earth, but also observation of other bodies, as well as these kind of more transferable leadership management skills, being able to kind of understand a whole mission pipeline from development to build to launch to operations and decommission, all within this kind of like responsible use of space ethos that we want to instill. So, yeah, we've been speaking to kind of industry partners, local companies in the UK space sector, and they are screaming out for graduates that with the skills that this course will provide. The reason why Scotland is so exciting about in this sector is Scotland, believe it or not, is the kind of heart of the UK space sector. We have two key launch sites being developed in Scotland. We have Sutherland up in the far north, which is a vertical launch site and will allow us access to these really interesting polar orbits, as well as a horizontal launch site getting built in Prestwick Airport just down the road from Glasgow. Itself, believe it or not, like the outside of California in the US. So we have a booming satellite industry booming space sector right here in the city of Glasgow. And many of those space companies are based here, and they will contribute both guest lectures and maybe even research projects to this master's course. And I hope many of our graduates will end up working for these really exciting new space companies. What the course aims to do is to give you a kind of holistic overview of space science, which is the study of basically all planetary systems and understanding applications from observing the Earth from satellites or observing other planetary bodies or asteroids using probes, understanding what impact that has on anthropogenic climate change, how we can understand climate change in the world around us from that orbital viewpoint, as well as how we've learned about the world around us by studying materials either that have been delivered to us through meteorites or been brought back by space missions from various bodies out in our solar system, to understand some of these big questions, like how do you build a planet somewhat. And so what this course will do and what this course aims to do is provide graduates all the skills to go into careers in the space sector, looking at kind of remote sensing of the Earth or other planetary bodies, processing satellite data to providing kind of like downlink services, or going into kind of more like extraterrestrial geology and geochemistry, understanding our solar system, and then the kind of more like holistic management leadership roles of designing missions, developing missions, understanding that whole mission pipeline, what kind of detectors, what sensors you want to put on a satellite or on a space mission, including literally rocket science and how to get the thing up there as well as doing this all kind of responsibly, understanding the policy, the laws around this, and engaging in those kind of more ethical, moral discussions about responsible, sustainable use of space. What you're going to learn is a whole variety of things. So these are our intended learning outcomes. I'm not just going to read them. I'm just going to kind of summarize them for you, but they're there if you want kind of more detail. What I'm really excited about this course is we're going to use the kind of vehicle of how have we explored space? What missions have we sent out into our solar system? What have they allowed us to learn? What sensors and detectors and components do we put on those to answer some of these key questions? So you'll go away not just understanding the key theories of solar system formation, planetary science, space science, biology, are we alone in the universe, but how we are trying to address those questions, understanding how fishing and aviation vessels work and how maritime things. There's a whole suite of things you can do using satellite data from space that directly impacts people on Earth. You'll be able to kind of like get those kind of more kind of soft skills like teamworking, communication, to communicate these really quite complicated ideas in a way that people understand, to be able to kind of engage with a variety of people from the public to also to policymakers and to industry, which I think is really, really important going forward. You'll also kind of help kind of develop policy and like learn how we kind of think about humanity's place in space, and take kind of responsibility for how we use the space environment in a responsible way. And I think the thing I'm most kind of excited about is the way we developed this course. For the majority of cases, we have aligned our assessment to be completely in line with the skills required. So for the majority of courses, not technically all of them, we've kind of got rid of the traditional exam format. And all of our courses are skills aligned. And what that means is basically you will end up with a portfolio of coursework that you have done that evidences how you've developed over the course, but also what skills you have. So, for example, some of our assessments are around building a narrative CV, which is kind of critical for applying for grants from the UK space sector, or writing that research proposal itself. Delivering, like not, sort of like, providing a presentation and a report about a piece of research that you've done to communicate that. So you'll basically be able to prove to any employer that you have all the skills that they're looking for because you've already done it in this course, which I think is very, very cool. The way the course kind of works out, the kind of different courses we have, right at the beginning of semester, we have these kind of what we call upskilling courses because we know graduates come from all over with a variety of skills. We have a requirement for mathematics and earth science, but if you don't have those core skills, we have an introductory course that you would take. So, for example, if you're a geoscientist that hasn't potentially done an awful lot of maths, you will come onto our course and do the mathematics fundamentals course to bring you up to speed with your maths to be able to help you engage with the rest of the course. Simultaneously, if you're a mathematician, a physicist, very, very happy with your mathematics knowledge, but you haven't done much earth science, we have our earth science introductory course to bring you up to speed with current understanding of the earth system. So, and then from there, you can engage with the rest of the course, no problem. And then we have some really cool courses like exploring the solar system, where we look at how we've used space missions to explore our solar system, explore the moon, explore Mars, explore the deep solar system, the Jovian planets like Jupiter and Saturn, the icy giants like Uranus and Neptune, as well as the inner solar system like Mars, Venus, and Mercury. And how we've come to understand our solar system through those missions. We've also got spaceflight dynamics, which is literally rocket science. It's all the mathematics and physics that goes into putting a rocket in orbit, putting a rocket in space, and also sending it to other planetary systems, other planets within our solar system. So that's why we need that kind of high end of mathematics, because that's quite complicated. We'll also explore different spacecraft systems, what components, what sensors, what device we might want to put on a spacecraft, and what kind of questions they can answer for us, as well as understanding kind of the hazards associated with the space environment. So space is an incredibly hazardous place. You're up in a vacuum. You're being bombarded by cosmic rays, the solar wind, and also micrometeorites. And so how do you keep your spacecraft safe, particularly if it's got humans on board? So that's a very kind of important course. So building on what we learned in semester one, like exploring the solar system, rocket science, maths and earth science, and the space environment itself. In semester two, we build on that, understanding some of the kind of key questions around, are we alone in the universe, in our astrobiology course, and what tools and techniques and missions have we launched to try and answer those kind of really important questions. Then our kind of numerical modeling course, which is a kind of key skill for any graduate in the 21st century, but particularly for space scientists to be able to develop software and also model some of these really complicated processes. And then kind of the course around designing and developing space missions from start to finish, from the idea to the kind of applying for funding, to building, to launch operations, and finally responsible decommission. And then that piece around kind of applied remote sensing, how we've used satellite and spacecraft to observe other worlds, including the Earth, to understand our solar system and also understand our environment. And on those courses, we're going to have representatives from industry, which is really exciting, to come and lecture on those courses, providing access to their software, providing access to their data sets, to be able to kind of get almost like real world case studies of how people have been using this kind of data, and then being able to kind of develop those skills yourself. And then the kind of final part of this, building all of that together, using all the skills you've got from the whole course, is to undertake a research project, either with one of our academic staff in a field that you're interested in, or potentially an industry placement with one of our industry partners in the local Glasgow or UK space sector. So all of that hopefully gives you all the skills you're going to need to have a very fulfilling career in the space sector and in space science. Finally, before I kind of go on to take questions, I kind of want to highlight, I think, one of the icing on the cake of this whole course is we get to go to a very exciting European impact structure during our astrobiology class. So we get to go outside, put our learning that we've got in the labs, in the lectures, in the course, and apply it to the real world. Going to this location, this is one example that we're looking at, which is the Reese Impact Crater in Germany, which is an amazing location, really, really beautiful. We'll stay in this little medieval village and then explore what happened when an asteroid strike hit the Earth during the Jurassic period, not just exploring the kind of catastrophic impact of the impact itself at the time for life that was around there, but also that kind of regenerative bit about how asteroid impacts are not only catastrophic, but also provide opportunities and safe havens for life. And so maybe these environments, while catastrophic when they happen, could also act as kind of these places where life could survive on planets that are much more hostile than our own. We're going to look into some and provide various opportunities to travel there, either like the kind of direct route, which would be a flight, or a maybe more eco-friendly travel option, which to be get a train down to Nuremberg. And that has a really cool opportunity where you can get these kind of European rail passes that are over a kind of a small period of time. So not only would you be able to have this amazing field experience, but maybe have a little break at the end of a long semester and celebrate a job well done and explore some beautiful parts of Europe as well after that field class. Cool. With that, thanks so much for your attention. Thanks so much for listening. I'm really excited about this course, and I'll be more than happy to take any of your questions.
Had a couple questions pop up in the Q&A. So
Good.
just as a reminder to everyone watching, please put everything that you would like to ask into the Q&A box along the bottom of the screen, and Luke will be here to answer anything that you've got. So please take this opportunity to do that. We've got a question. Can you talk a little bit more about the research project?
Yeah. So this is something you'll do basically at the end of your program. So we'll have all our semester two courses, and then over the summer you'll undertake this kind of research project. Um, so there's a kind of two kind of flavors of this. A lot of our staff who are experts in a variety of space science field will put forward projects that you can apply for and sort of gauge, basically that are aligned with their expertise, but hopefully also aligned in your interest in space science. So whether you're more aligned with engineering, some of our engineering colleagues will provide projects around kind of engineering the space sector. If you're more interested in kind of astronomy and physics or solar physics, our physicist colleagues will provide research projects on that. Or if you're more interested in kind of like extraterrestrial geology, myself, Lydia, and various other folks will provide research projects there. So there should hopefully be a quite nice diversity and quite nice spread of research projects in a variety of the space science field to suit everyone's interests. And then we are still in negotiations, but we are hopeful we'll be able to offer some industry placements where instead of doing that research project, you'll be able to go to one of our industry partners and do essentially a little internship, which will be the equivalent of one of those research projects, and get some basically hands-on industry experience. But yeah, we're still negotiating those with our industry partners. So yeah, watch this space for that.
Sounds awesome. So exciting to hear about. Um, we've got another question. Could you talk a bit more about completing the course part-time over 2 years?
Yeah, good question. So there is the option to do it part time. It's a very kind of bespoke package when we do that. It's not certainly not the usual way, but it is certainly possible. Um, what we will basically do is talk to you and talk with you about what your needs are around that kind of part-time study, and find a way to allow you to engage with all the course over that 2 years and get all the learning, so you won't miss anything. We have to do that in a clever way. So, for example, some courses build on each other. So the Exploring the Solar System course leads directly into the astrobiology course. So it might be a way where in the first year of your part-time study, you would do Exploring the Solar System and then astrobiology. So there's no break. And then the next year, you do more of the engineering courses. But really, we can kind of design that course to suit the needs of that particular student. So it will be a very case by case basis, but there are certainly solutions that we've looked into and explored. So yeah, if you're looking to do it part time, I encourage you to get in touch early, and we can figure out what the best way is for you to look into this course.
We've got a question here about how many modules we can take, and I suppose we kind of touched on this a little bit in the presentation. But this person's particularly asking about the number of credits that there are. So maybe just a wee
Yeah,
recap of how many credits per semester.
you'll do 180 credits on this course. All the credits are core except for the two option courses, which is Introduction to Earth Science or Introduction to Mathematics. And you'll do either one of those depending on your background, and that will bring you up to the 180. So you'll get to do all of those really exciting courses.
Thank you. Um, Ethan is asking, what forms of assessments are used for grading?
That's a really good question. We use basically the whole portfolio of assessment styles. What we've really tried to lean into with this course, though, is skills aligned assessment that are basically pieces of coursework that not only test your understanding and knowledge and curiosity of the discipline, but also give you a skill in its own right while you do that assessment. So there will be some exams, but not many. The majority of them are going to be coursework based assessments or working in teams. So you'll basically have a mission design portfolio where you'll plan and develop a mission. You'll write a grant in the same style as the UK Research Innovation Office would require. You'll write a CV. You'll write a research report on a piece of work, research that you've conducted. You'll show skills in kind of critiquing a science paper. You'll review something. So all the skills that you would need in the sector, you will have done and be able to show your employer you've done during this course. So yeah, hopefully our assessments are very much aligned with the skills required, not just the knowledge required. Hopefully that makes sense.
Definitely does. That sounds great. Hopefully, like a great transition into employability for straight after the course as well. So, sounds fantastic. We've got a question in the comments, which was, how focused will the engineering bit be in the course as someone who would like to transition into space systems eventually?
Yeah, really good question. So there is quite a substantial amount of engineering. Um, I'd say if you are looking to build a satellite, like physically get hands on and weld satellites together, this is not the course for that. We had to make some choices. We could not do absolutely everything the UK space sector wants. And so we really focused on mission design and development, understanding the mission pipeline and understanding processing data at the back end. Um, but having said that, there is a lot of engineering courses, so you will understand how you put a satellite together. You just won't do the physical building of one, and how a mission operates, and how you process that kind of data. So yeah, there are I think about 30, 40 credits of engineering courses. From everything from literal rocket science to mission design and development, spacecraft systems, etc. And
Awesome.
then, of course, you have the opportunity to do an engineering based research project if that's your kind of key core interest.
So cool. And you can tell everyone that you're studying rocket science, which is really the number one thing, isn't it?
Yeah.
Awesome. We've got a little question about the funding for the field trip. I don't know if you'd like to touch on that a little bit.
Yeah, absolutely. So, as part of your tuition fee that you would pay to come on the course, that will include your accommodation, a bit of your travel, and your it's like food subsistence while you're in the field class. So there won't be like an additional cost to the field class, and we will subsidize, I think, part of the travel, but it will very much depend on your decision on what you want to do afterwards. So, do you want to take us up on that idea of traveling by train, getting that European travel card, and then everything after that is up to you. You can go explore the rest of Europe and have that kind of really fun experience. But that extra bit wouldn't be covered by us, but the learning experience will be covered as part of your tuition fees. So that's kind of very exciting as well. So there isn't like a hidden extra cost associated with the field class.
Awesome. And at the start of today's webinar, we had a couple of people joining us from Cameroon and Zimbabwe and really exciting places
Amazing.
across the world. So I think the prospect of doing a field trip in Europe and getting to travel around Europe for a little bit might be quite an exciting thing to hear for some of these people as well. Um, we've got a question about how many places are on the course. I don't know if you could advise on that, Luke.
Yeah, that's a really good question. So I think basically our field class gives us the upper limit, which I think is on the order of 60 students, and so 60 places, because that's the limit of the accommodation in Reese. So yeah, so that's currently our maximum. Of course, if we are inundated with students, I'm sure we will come up with a solution to that.
Excellent. We've not got any more questions currently, so please, if you are attending right now and you have got a question, this is the time to put it in the Q&A. We really, really want to answer anything that you've got, or if there's anything today that you felt maybe wasn't fully covered, or like you feel like you maybe want a little bit more information about something, please put it in the Q&A. This is your chance to ask any questions. There's also the chat down there. Feel free to put it in there too. Oh, one question popped up. One last question. Can you talk a little bit more about any PhD opportunities?
Yeah. So what I'll say is this course does kind of give you all the skills that you would need to put forward a competitive PhD application. It doesn't directly lead into a PhD scheme. There isn't like a scheme that comes at the end of this for PhDs, but there are a whole suite of PhD opportunities available at the University of Glasgow. Many of them are within space science. Those applications will be very, very competitive across the UK space sector as a whole. What I would encourage you to do, though, is during your time with us during the master's program, is start talking to potential supervisors and engage with them, and particularly like align, like if there's someone who does something you're really, really interested in, start having those conversations early, and they might be able to develop a project to apply for funding for a scholarship for a PhD, or might know of an opportunity for applying for a scholarship. But yeah, so there will be lots of opportunities for PhDs that you'll be able to do after this, but there'll be a competitive process to apply for those. Hopefully that makes sense.
Yes, I think it really does. We've got a couple more questions popped up there while you were chatting,
Brilliant.
which is great. Um, will the course touch on the topic of exoplanets?
Yes, it will. So exoplanets are a key part of kind of space science, and they're a key way of basically understanding how special or ordinary the Earth is. So we'll be looking at hopefully some really exciting new data from the James Webb Space Telescope, which is going to discover thousands of new exoplanets, but also kind of looking at mission data from Hubble. So there's a really cool data set that got beamed back by the Hubble Space Telescope, where they saw the light from a star passing through the upper atmosphere of a planet that was in orbit around it. And that light got impacted by the composition of its atmosphere. And from that, we were able to tell that there was water in the atmosphere of that planet. And water, as far as we know, is vital for life on Earth. So that is a key data set to show that water is not just present on Earth, but is also present around other planets in the galaxy. So yeah, we'll be talking about the latest, greatest discoveries in exoplanets and how that maps onto our understanding of our own solar system and Earth's place in that.
So cool. So it sounds amazing. We've had a question. Could you elaborate a little bit more on the job scope after this course?
Yeah, absolutely. So, as part of building this course, we had a load of um, basically like interviews and discussions and um, chats with industry, particularly like local industry, like Spire Global, Clyde Space, Skyrora, Orbex, which are local satellite companies and launch companies in Glasgow. And we basically said, this is what we want to do as a course. Are we missing anything? And then they kind of gave us the idea about, oh, maybe we want the modeling course to be put in there. So that's why that's there. Um, and basically, at the end of that discussion, I was like, all right, so if we delivered this course and we built it, and there were jobs available in the UK space sector, would you employ our graduates? And they basically just said, yeah, in a heartbeat. So yeah, so I think obviously there'll be an application process and it will be very official, but it sounds like we've built a course that the UK space sector really, really needs. I'll give you a quote as well. So we also did interviews and chats with esteemed members of the international academic community, people who've worked with the UK Space Agency, with ESA, written like reports about how we should explore Mars the best. And a lady called Caroline Smith, who is basically one of the top people at the Natural History Museum in London for extraterrestrial materials, basically said this is going to be one of the most important courses in UK space science. So yeah, that's the kind of backdrop, and so we're very kind of excited to have that kind of sort of endorsement from both the industry sector and the academic community. So I am I'm very confident. Well, we haven't had I'd love to give you stats on how many of our graduates are employed, but we haven't run the course yet. So we'll have that data next year. But I'm very confident that the skills we're going to give you are going to enable our students to have a very fulfilling career in the space sector.
Um, we have got another question from someone. Just a reminder to everyone who is in the webinar, please add any of your questions to the Q&A. We've got a couple still to go. How much physics and astronomy is involved in the courses that come under geography and earth sciences? Because this person comes from an astrophysics background, so would love to know how much that comes up.
Really good question. So there'll be quite a bit of astronomy, depending on how you define astronomy. If you're talking about just observing things with telescopes, that is going to be a key part of the earth science and geography courses. Particularly, I like remote sensing of the solar system, remote sensing of the environment courses. That's basically astronomy. But we will also have basically our solar physicists giving you a really good overview of the space environment, how the sun affects the Earth's moon system, and how it affects spacecraft in orbit around our own planet, but also elsewhere in our solar system. So I guess kind of in summary, there is a lot of everything. So you get this kind of overview of planetary science, space science, astronomy, astrophysics, engineering, solar physics, etc., as well as mission design, operations, and policy and planning. So, yeah, I'm not sure if that answers your question particularly clearly, but it is involved. There is some of it. It's within this whole package of learning.
We've had a question in the chat. What will the prerequisite be for the astrobiology module, and what will it cover, if you can elaborate on it?
So the prerequisite for the astrobiology course is to have done the Exploring the Solar System course, which to get onto the Exploring the Solar System course, you'll have had to be accepted onto the Space Science course. So anyone who's accepted onto the degree program itself will be able to do the astrobiology course. And what will it cover? So basically, yeah. So what will it cover? The whole course is basically, in a nutshell, how have we gone out into our solar system and into our wider universe to answer the question, are we alone? To see, like, is Earth special? What components had to come together to make our planet? When we look into our solar system, do we see anything similar? Where might be the best places to go look for evidence of life in our solar system? Where have we looked already? Why haven't we looked in the most important places? And kind of responsibilities around that. But also, again, going back to the exoplanet point, how have we looked out into our galaxy to look at planetary systems that are forming today, to understand how habitable worlds might form in the first place, but also exoplanets around other stars to see if they might be in the habitable zone or have water in their atmospheres or all the other ingredients. So through the lens of the missions and the probes and the telescopes we've used to answer that question, you'll get a deep-seated understanding of our place and the kind of likelihood of life elsewhere in our solar system or in our wider universe.
I've had a question. Can you touch on the industry placement opportunities?
Yeah, that's a really good one. Again, those are still in development. We're talking with our industry partners. But basically, those will be, if we manage to get those kind of all signed off, local satellite companies in Glasgow will offer to take a certain number of students per year on industry placements, and there'll be a competitive application process probably towards the beginning or end of semester 2 to get onto those. And there'll be an interview process by the industry partner to basically select the students that they want on that. So it's not like a guarantee that you'll go on an industry placement, but there we hope will be opportunities to apply for them. And so for some of our cohort will be able to go on those.
So, what an amazing opportunity for someone studying space science. How many contact hours could we expect per week, for example, between lectures and labs?
That's a good question. I don't have the exact numbers off the top of my head. But I think it's on the order of around 60 credits per semester. That equates to around, it's like 10 lectures per So I'm doing maths live. That's never a good idea. Um, my kind of best guess would probably be on the order of 10, 15 hours of contact per week, depending on what week it is and where we are in the semester. Because some courses will overlap and then there'll be more contact hours in that week, and then there'll be less at other times. Um, that having said that, as well as the contact hours, we also kind of have an expectation that you'll go away and do your own learning. Outside of that, so almost like it's like 1 to 4, the ratio we expect. So for every hour of contact you have, there'll be 4 hours that you would do of your own independent learning to kind of explore the topic in more detail. And I think that's a really lovely opportunity about being at university in general, is you have that dedicated time to become an expert in that field. And so you should really embrace that and not just be like, oh, I'll just turn up to the lecture and the labs and then I'll get that content and that'll be great. It's like a good opportunity to like explore the wider field and embed your learning into the wider environment.
Thank you. And we've got a question. Is it possible to do the course without explicit physics experience at university, but having done physics at A level?
Absolutely. So what we say in our wording is first year physics or equivalent, and we count either Scottish Advanced Higher Physics as equivalent, or indeed A level physics would also be equivalent to that. And there's a whole kind of variety of international equivalences there. So if you have don't worry if you don't have physics at university level 1 level, like first year level, if you have it during your kind of studies leading up to that, to going to university. So as long as you have that kind of physics backbone at sort of like Scottish Advanced Hires or A2 level, you'll be absolutely fine.
Thank you, Luke. We've not got any questions left, so take a little breather for now. And if anybody has any questions, any last minute questions, then please put them into the Q&A. But hopefully, this morning has given you a nice overview of the space science course. We would love to see you all in the cohort for this year. If you do have any further questions throughout the day, if it gets to later on and you think, oh my goodness, I should have asked Luke this question while I had him, we've got this email, which I have just popped into the chat. Please save that email just now, copy it and pop it into a note or something. And this email address you can use for the rest of today, and honestly for the next couple of months. If you've got any questions whatsoever about space science, we've got some people on the other end of that email to answer any questions that you've got. So please use that for any questions that you have. We've not had any more pop up, so I think we will leave it there. I think I'm going to say that just as another one pops in. But thank you, Luke, so much for your time today and for being so passionate about this course. I think it's going to be absolutely fantastic. And yeah, if anyone has any more questions, please email us at that email address. We've also got a couple more sessions going on today. We've got an employability session happening on YouTube at 11:30, which we would really like for some of you to come along to. There's also some central events happening today online for accommodation, for finance, for scholarships. So please check the event schedule. It's on our webpage, and have a little look and see if there's anything that you would like to go along to today. But for now, I think we will leave it there. Thank you all very much for coming, and we hope to see you when Space Science starts soon. Right.
Yeah, thanks so much for coming, everybody. Hope this was informative about the course, and yeah, hopefully welcome many of you next year or this year. Gosh.